Okay. Thanks for joining me this evening. My name is Julie Lyderson, and I am the Electronics Department Navigator at North. And what that means is that I assist students in kind of finding their way, finding the program that's the right fit for them based on their interests and academic goals. I am there to help students persist through their program and ultimately land employment in the field that they're training in. So really, I say I do kind of three things. I am describing the program options, the academic pathways, and helping to interpret a lot of the confusing pieces of the higher education experience in college, the hidden curriculum, and help connect students with individuals and resources that are really critical in helping them to complete their program and ultimately secure that target employment. This PowerPoint will be available on the college website, so you don't feel as if you need to take any notes necessarily. You're welcome to put questions into chat, and I'll check that periodically. And of course, you're welcome to just see what I share here and then see what questions come up. And I'm certainly available for follow-up later. Always glad to have talk with people by Zoom and have you come in and meet with me and show you our facilities and all of that. So we will go ahead and move on to our first slide. There we go. So the agenda today. So the focus in this session is the electronics department at North. But I am going to give a little bit of a quick overview of North Seattle credentials that just helps it make it a little more clear what all of your program options are, but some specifics of electronics. I'll talk about applied instruction because we offer applied degrees and explain what that means. How long does it take to complete our programs, our certificates, our degree options, and talk a little bit about the job market. Where is there demand for these skills that we train in? Who are some of the employers that are hiring our students? How much do they make? And then, of course, the last slide will be contact information, so you can always reach out to me. And I'd like to begin by defining this term credential. When we're talking about credential, I'm just referring to it's an official documentation verifying that you have specific skills or certain qualifications. When we're talking about credential, we could be referring to a credential earned through an apprenticeship or in a credential earned because you have a professional certificate industry. But tonight we're talking about college credentials. And so what that means is our Bachelor's of Applied Science degrees. Those are credentials at North. We have 5 of those listed here. We have our transfer degrees. Those are Associate of Science degrees, and generally those are for students who want to complete a 2-year degree and then move on to a bachelor's program that may be at one of the Seattle colleges, or it might be at another college or university, and they want to have generally junior class status by the time they've finished their transfer degree at North or another Seattle college. And then we've got our Applied Associate of Science degrees and our professional certificates. And that's where the electronics department programs lie. The Applied Associate of Science or AAS degrees, they're really about preparing folks for employment. They're not about necessarily transferring to another program, although we do have some transfer degrees. I'll get into that. Professional certificates, those are shorter term. Our shortest credential in the electronics department is 2 quarters. More often it'll take students 3 quarters, depending on the quarter that they begin. We're open enrollment, so students can start any quarter. It's really up to you. And from there, I like to kind of point out, some people are still considering, why do I want to even consider post-secondary training or training beyond high school? And I think it's a really important question to ask. And I think one of the most practical responses to that question is answered by looking at the demand of the workforce right now and answering that question of what portion of positions are requiring some form of post-secondary education. And what we're seeing is that it's about 70%, so 7 out of 10 jobs right out of the gate are requiring some form of specialized training beyond high school. So I think that's a really important figure for us to all be aware of. And I've noted the resources at the bottom of this slide, so you can certainly dig into that further for more information. So at North, we have one large division that is called the Workforce Instruction Division, and that houses all of what we call our Prof-Tech or professional technical programs. It includes, as I mentioned on a previous slide, or actually, I guess I didn't mention that yet. We've got our Applied Associate of Science degrees, a list of those there. You'll see electronics is included, that's our department. We have the AAS-Ts. When you see the T, that just indicates that this is a transfer degree. So it was designed with the possibility of the intention of transfer in mind. I'll tell you a little more about that in a couple of minutes here. The bachelor's programs, the BAS degrees, those I did reference on a different slide. At North, we have 5 different bachelor's programs. And it's common that students will complete an associate degree at North or one of the Seattle colleges and then move into a bachelor's program. And electronics. So we'll zoom in a little bit now into specifically the electronics department. This is where I am. We have 5 degree pathways, and we have certificates embedded in most of those pathways. So I've got a list of those now on the screen, and I've differentiated those by color. So you see where the title of one degree starts and ends, and then the next one begins. So we have our electronics technology. We have our healthcare technology management / biomedical equipment technology degree. And we call that our biomed degree for short, because it's got a long title. We have industrial power and control, mechatronics, electronics engineering technology, which is a transfer degree, and IT controlled electronics. And I include the IT controlled electronics because although it's an IT department degree, it's housed in the IT department, it does require about 40 credits that are electronics. So it's a blend of electronics and IT. And then each of these, or in the next column that I just added in, you'll see those degrees that have certificates embedded. So the electronics technology has 3 different certificates embedded within that certificate. The industrial power and control degree in red has a certificate embedded, and I put new for spring only because we're in the process of modifying that certificate. We've changed the name, we've shortened it. Mechatronics has a certificate embedded as well, and IT controlled electronics. And it can be helpful to think of embedded certificates as like the rungs of a ladder. So the shortest certificate we have is Aviation Electronics 1. Let's say you complete that in 2 or 3 quarters. A student might then say, you know, I really want to get my foot in the door in industry. And they might say, you know, I think I'll continue on and complete the longer certificate, which would be Aviation Electronics 2 or Electronics Technology. And from there, they could continue on toward the degree. It just depends on what each individual's goal is. And the majority of our students tend to complete either an associate degree or at least a 1-year certificate. A 1-year certificate really opens a lot more doors in getting into industry than the shortest certificates do. And, you know, I think folks who are getting into electronics, some people have been like, you know, hobbyists, or they love to take things apart and they've always had this interest. And others are just kind of assessing, do I even care? Do I have an interest at all? Is this relevant to me? And so I like to share, you know, just on a personal level, on a career level, you know, our immediate community and globally, where is this even relevant? So I want to share some examples that are just the most, some of the most common or readily observable examples in most of our lives to show kind of the relevance. And it's starting with just like daily routines or getting me where I need to be on time. I don't think I'd be doing that without my, you know, alarms, of course, you know, the lights that we're using, any of these screens, the screens we're using now, or gaming consoles, you know, certainly throughout pandemic, life on screens is quite common. You think about the food that we eat, and, you know, how do we grow it? harvest it, prepare it, store it. Same thing with our clothing, materials processing and fabricating of garments and cleaning of garments. Our housing, from raw materials to harvesting and producing those materials, the construction equipment involved, design tools, and then of course in the medical field, and in chemical processing, biomedical equipment, pharmaceuticals processing. We see more and more robotic assists in surgery, transportation, and I usually use that term logistics. And logistics, we're just talking about the moving of people and product. We're all familiar with Amazon, for instance, so it's a really big industry, logistics. Of course, space travel, drone technology, and I think it's just really fair to say that electronics at this point, electronics devices are really an important part of our day-to-day life today and as we move forward. And I would take that even a step further. And I think it's important to acknowledge that, we're using electronics now and technologies where we have things like robots, artificial intelligence, and, automation technologies that are capable of doing human work with more ease and efficiency. And that's, that's a really important fact to consider as you're exploring, finding that right career fit for you. So program features, and I don't see any questions right now, so I'm going to just continue on. The things that I like to highlight as some of what I think are the most important core features, and I've got about 5 categories here that I'll share. And the first is that we are applied training technician programs. And applied just means that we are, you're using what you're learning in your lectures. So we use a lecture and then hands-on in the lab application kind of format. Our students are launching first careers, our students are career changers, or they're looking to advance what they're already doing in industry. We really emphasize this practical knowledge of theory and technical skills that you have experience working with, a variety of experience, a variety of equipment, in our labs. The math that's involved in all of our pathways, a little different for the transfer degree, but in all of the other ones, this is math that's contextualized for electronics, so it's very relevant. We have a workforce focus. So our programs are designed for the workplace. So we're developing our programs in cooperation with industry. We work with technical advisory committees, those folks in industry, as we're building and modifying our programs regularly to make sure that we're aligned with industry needs. And also make sure that our students are completing programs where they really have options in the workplace now and in the future. Our instructors have practical work experience. They come to us from industry. Some of our faculty are working full-time in industry, but they come in to teach a class once or twice a year, something specialized. So maybe aviation electronics, or working with biomedical equipment or robotics. There's a great opportunity within our program because we are a large department, 5-degree pathways, and students don't always know what's my right fit here. So we have an opportunity for students to switch from, they thought mechatronics was the right pathway, and then they realize, what, I think industrial power is more my direction. And because we have core electronics classes that are required across all of these pathways, students can make these transitions oftentimes without losing any time in completing their program. And we're looking at, these are skills that are relevant, as I mentioned, across industries. So super practical. Internship opportunity, often get this question, are there internships involved? And I'll share detail about that in a minute, but we absolutely encourage these work-based internships, opportunities to get experience in the field for academic credit. It is required for a couple of one of our degrees required, one it is strongly encouraged for, and optional for the others. And this is a good opportunity to point out that we do frequently hire our students as teaching and lab assistants, which is really excellent employment experience. And last category I'd like to really highlight is just that we are a really diverse learning environment. It's part of why I'm here at the college, because the peer learning opportunity is super valuable. And we don't have such thing as a typical student. Our students are high school students who are exploring with Running Start. We have those who are, as I mentioned before, they're first job seekers, or they're retraining to move into something entirely different from what they've been doing, or they're incumbent workers. They're already working in doing something somewhat related, but they need to skill up. We've got hobbyists. We have engineers who come to us and say, you know, I suddenly I'm in charge of, you know, this automation that's happening in my division, and I don't have the skill set for that. Or it might be that they're like, you know, I don't enjoy sitting behind a desk and I really want to do hands-on work. And our students are from around the world. So that's a pretty cool place, a pretty exciting element of our programs. So a little more detail on the internship piece at this point. Great opportunity to try on an employer and, you know, different type of environment and see how that feels for you. Super practical. So a 4-credit internship. So you're getting academic credit. It's built into 2 of our degree pathways. One is our biomed degree, the one with the very long title. All of those students complete an internship with a hospital, a medical facility, medical equipment manufacturer, and that's usually in their final quarter of the program. It's possible they'll have 1 more quarter to go, but there's a certain number of classes, the majority of which need to be completed before they're prepared for an internship. And we often have students, you know, I was talking with a student just this week who she was hired into a position before completing her degree. She's now completing her internship on the job because the demand is absolutely there to hire students before they're done with their programs. The Mechatronics degree is another program where we built in an internship, but we also, this is an optional one. Students may choose to complete additional electronics courses in place of an internship if they prefer, or if that's just a better fit for their, you know, their life and all of the variables that people are juggling while they're going to school. I like to point out the Boeing summer internship, probably because that's the most popular one with our students. We have a number of students every summer who intern with Boeing. And so that's a really popular one, but we have students who are going into other internships that they've, you know, sought out themselves sometimes to an employer that they're really interested in. And we kind of, you know, they approach them and say, I'd really like to intern with you. And this is what I'm studying in school. And so we're really open to that opportunity. And we have some regular internships as well available for students. And so I think just important to summarize here that students may choose to complete an internship, even if it's not a required element of their program. And I'm talking even outside of the electronics department, it can be a really valuable experience in it, even if you're not getting academic credit for it. So it wouldn't appear on your transcript. This is still something that would be valuable to have on your resume, but certainly for the experience, for the building your professional network opportunity. And students do apply for their internships just as they would apply for a permanent position, and we support you in that effort. And I am monitoring chat, and I'm going to keep on going. So now the practical nuts and bolts of how quickly can I complete these programs? How long does it take to complete a degree? Well, we had to talk about credits. So most of our courses are 5 credits. A full-time student is usually taking 15 credits or 3 classes. And that's when I'm talking about fall, winter, and spring quarter. Fall, winter, and spring are about the same length. They're 11 and 12 weeks long. Summer quarter is more condensed. It's only 8 weeks long. So it's common that students who are attending summer quarter will take 1 or 2 classes instead. The program completion pace. So if I assumed somebody was attending full-time, It would be 7 or 8 quarters typically to complete their associate degree. It would be 2 to 5 quarters, a range typically, to complete one of our certificates. And what is a typical schedule? So our classes meet, most commonly, they'll meet twice a week. So we're talking on Monday and Wednesday, or Tuesday and Thursday. That's the most common schedule. We have some classes that are hybrid. Those classes are just meeting 1 day a week. And there's still this expectation that you're completing work that's equivalent to another class meeting, but that's, according to your own schedule. We don't have classes on Fridays, usually in electronics. There's one exception, and that's a 1 credit soldering class. And it's our only 1 credit class. And when that class meets, they usually meet just once a week for the first 4 weeks of the term, and then that class is done. So it ends early in the term. Our typical hours. So electronics, our classes generally start at either 11 a.m., at 2:30, or at 6 p.m. And we do try to vary those hours from quarter to quarter. So some classes say DC electronics, for instance, it's offered every fall, winter, and spring. It's not offered in summer. So fall, winter, and spring will vary the hours, the time of day that it's offered each of those quarters. And a question I get all the time too is about transferability. Will my degree transfer to another college or university? And I'll share the 5 images of the 5 degrees in just a second. But our degrees, we're designed for the workforce. So we're not designed to be transfer degrees. There is an exception, 1 degree, our electronics engineering technology degree. But I also like to share the tip with students that when you're looking at individual classes, so you might be in a program that's not designed as a transfer, but there are individual classes that would be transferable. So when you see the ampersand sign, like for instance, English ampersand 101, or a history class with the ampersand and then the number, that ampersand or that am symbol is a signal to you that that is a transferable class. So English 101 at North is easily recognized at the University of Washington as English 101. That's part of the common course numbering system. But when we're getting into some technical classes, like maybe our industrial robotics class, and we call it EET 138. Well, another class might, another college might offer a really similar class, but they'd call it something different. It's not part of common course numbering. So, and sometimes those classes will transfer, but the ampersand is kind of your signal that this is a it is a transferable class. So what do you learn in electronics? And I'm going to give you kind of a list breakdown, quick summary of our classes just by short version of the titles. So DC and AC electronics, math, as I mentioned, contextualized for electronics, robotics, a couple robotics classes, physics, that's a practical knowledge applied to the technical field, some basic soldering, fiber optics, PLCs or programmable logic controllers, which you could think of as kind of industrial computers, hydraulics and pneumatics, aviation electronics, so all of the controls on commercial aircraft, IT essentials, so I think basic hardware and networking, semiconductors, solid state electronics, digital electronics, and about energy generation and conversion. Precise motor controls and drives are a really big deal in industry. Metrology, which is like measurement science, and biomedical equipment. So again, the equipment used in hospitals, medical facilities. And we really emphasize the applying what you're learning in lab. And I'm not including a video in this. I've got links to videos, so you can look at those later at your leisure. But just to give you a general picture of, we've got 3 main electronics labs. Those are located in what we call the education building, the ed building. Our lecture halls are in that same building as well. So it's easy for students to have lecture and then take a little break and then move into the lab and apply what you've been learning about. And these images, they just show some different workstations. The upper center image is an industrial robotic arm. On the right, upper corner is hydraulics, pneumatics trainer. Down in the lower left corner, those are some PLC, programmable logic controller trainers. The middle lower is a student working on our industrial power lab. And on the right, we've got it's a photo of a motor. Students who complete the mechatronics degree will also work in the shop at Shoreline Community College. And I'll say about that in a minute. So I want to quickly give you 5 slides, which I'm going to go through pretty quickly because our time is going, well, we've got about 14 minutes left. Electronics technology, you'll see each of these slides gives you kind of an overview, big picture of what's this degree about. It's going to show you the program options, or are there certificates embedded within that certificate, or excuse me, that degree. I put a note by the electronics technology certificate because we're shortening that and we'll have the new version of it available summer. So if somebody says, I want to do a true 1-year certificate, we want them to be able to complete it in 1 year. And then at the bottom of each slide, I'll tell you what differentiates this plan or this program from the other degrees. And in this case, this pathway, there's an aviation electronics class, there's some advanced digital electronics, and there's a couple of technical elective requirements. So if you're interested in 3D printing or taking an engineering class or taking some additional chemistry or something, you have opportunity for that. The next slide here shows the electronics engineering technology, and you'll notice it's an AAS-T. It's a transfer degree. It differs from our other degree pathways in that this one is going to require some of those several calculus classes, several engineering physics classes. Those are classes that would be transferable to any college or university for an engineering program. But this program was created in partnership with Central Washington University. So students could complete this, the EET, AAS-T, to use a lot of letters, at North, and then apply to go to Central Washington University in Ellensburg and complete their bachelor's in electronics engineering technology at Central. And it's a great degree that's got just a mix of transferable classes toward any engineering program and this practical application experience working with a variety of equipment in our labs. Next, third degree we're going to look at is our biomed degree with the long title. So again, working in hospitals, medical facilities, medical equipment manufacturers. And what differentiates this from the other one, and I say differentiates it because remember, there's a lot of the same core electronics classes that are required across all of these degree pathways. But this one's going to require a chemistry course. It's going to require a medical terminology, project management, and of course the internship requirement. And there's a link to a video you can watch to learn more about this program. The mechatronics degree is really unusual because it is a shared degree between 2 colleges. And mechatronics is a field that combines multiple disciplines. So it's like several engineering subfields combined. The term came from combining mechanics and electronics, but you could say electronics, mechanics, industrial automation and control, and robotics. So students complete a certificate at North and a certificate at Shoreline, and then those stack together or combined form the mechatronics degree. So it's kind of like a cross-training degree. Then we have, and again here I've got, there's a link at the bottom that you should view that. I didn't want to show it here today in the interest of time, but this is specific to our mechatronics program. Industrial power and control. This is a degree where you're similar to mechatronics. You're spending a lot of time in our industrial power lab. You're working with high voltage. what differentiates this is a couple of classes that are listed here at the bottom: industrial motor controls and drives, energy generation and conversion. And what I found is that we don't train electricians per se, but I do, when we have students come to us who are interested in becoming electricians, and maybe they want to pursue an apprenticeship to become a journey level electrician, and they're trying to improve their candidacy for that because they are competitive getting into these apprenticeship programs. And so they may come to us and take courses. And this tends to be those who are interested in becoming electricians. I tend to see them move into this particular program. And so we're moving into the home stretch, and in checking time, we have about, oops, just a moment here. We've got about 9 minutes to go, and chat is looking good. So employment outlook. I want to share some data about Seattle and King County area, and I've listed the link below, which is a really handy place to spend some time looking at employment in our area and looking at, what's the demand and what are people making. It's fair to say that students who graduate from our programs with associate degrees tend to start at an hourly rate of $24 to $28 an hour. So that's $50,000 to $58,000 as an annual salary. There are certainly outliers to that. And we've seen students with a lot of overtime opportunity if that's something that they choose to do. But what I did is I took two job titles that really well encompass our training program. So we've got electrical and electronics repair, commercial industrial equipment, and avionics technician, which is just aviation electronics technician. And I'd just like to point out there that you can see the 50th percentile pay rate for each of those positions. So one is at about $40 an hour and the other one at about $45 an hour. And I think just pointing out that those are the average for folks working in those positions. So we're talking people who are brand new with very little or no experience, as well as those who have been working in that kind of role for quite a while. And you'll be able to, if you go to the site too, you can kind of look at the look at wages based on level of experience. And you can browse by different careers. And so where do our students go? And this is just a list of some of the places where we've seen students go recently, or some of the regular employers that are hiring many of our students. So Amazon, pretty familiar to everybody. Boeing hires a lot of our students. We've got about 3 students I can think of at Blue Origin right now. Crane Aerospace and Electronics. Pre-pandemic, we had at least 1 student who interned with them every quarter. They've hired quite a few of our students. Directed Machines is like a smaller employer. They make land maintenance robots and had a mechatronics students go there not so long ago. We've heard of Fred Hutch and Honeywell. JLL is kind of industrial facilities management and real estate. Corey Electronics up in Everett. Outdoor Research, you may know from their kind of technical outdoor gear and equipment, and they kind of retooled and opened a new PPE production factory when pandemic struck to outfit medical providers. Had a student move there. Science Center, all of the Providence and all of the hospital and medical facilities in this area are going to have North Seattle students trained in our biomed program. So we've got a couple I know of right now who are at Seattle Children's. We've got many at UW Medicine. We've got Harborview, so all the hospitals. Rockwell Collins Aerospace, Cinrad, they manufacture CO2 lasers up in Mukilteo. Sistema, Taylor Farms, they are obviously food industry. Thermetrics is over in West Seattle, and had a student go there recently, and they manufacture these, they work with kind of wicking fabrics, and they manufacture these really advanced, this is kind of my layperson's representation of it, but these mannequins that test high performance wicking fabric, and they're like, $500,000 robots or mannequins, excuse me. But this is just kind of a sampling of where students land. And this is a great opportunity as our time is going down. I just like to point out the paying for college. Now, if you are a student who is graduating from a Seattle public high school, definitely want to know about Seattle Promise. What is it? It's tuition-free attendance, so it's up to 90 credits for a student and additional support as well. You do need to graduate from a Seattle public school, one of our high schools. Who's eligible? Any graduate to apply during their senior year. Doesn't matter what your income is, doesn't matter your country of birth, your GPA. When do you apply? The deadline every year is in February or March. And it's for those seniors that are graduating that year. You could attend North, South, Central campus, any campuses. And why should you apply? And this is, I think this is some of the a critical piece of why people should consider our community and technical colleges is small class size, knowing your instructors, great access to them. In our case, super hands-on, practical opportunity, our instructors with specialized training, saving money, opportunity to kind of explore your interests and take a chance on taking classes that you might not want to commit to otherwise, but just to really find your fit. All of the high schools have specialists who are supporting the Seattle Promise. So I've got a link there if you want to find out who's working with your high school or your child's high school. And folks who are not in high school and who are more mature individuals, or there are other funding options that I would be glad to talk with you about. And excuse the cat walking across here, sorry. Okay, and I think we're really down to the end. We've got about 3 minutes. So I want to point out this really interesting study. There's this group called McKinsey Global Institute, and they're a think tank, and they're really focused on the labor market and the economic impact of technology and innovation. And they did this study, and this came out in 2017, and they looked at more than 800 different occupations and broke those down into the specific work activities. And they were looking at, well, of these activities, what has the potential to be automated? And this was based on, existing technology at that time. So like 2017 technology, and we know technology obviously is rapidly changing. And I want to share just a couple of three of their key findings. They found out that 49%, so about 50% of activities that people are paid to do on the job have potential to be automated by adapting the existing technology. They also found out that there's only a small fraction of jobs that are entirely automatable or entirely robot proof. And they also said that about 60% of occupations have about 30% of activities involved in that job that can be automated. And the reason I share this is because I just think it's really critical that we think about changing technology now and how it impacts our daily lives, how it impacts the jobs that we do, and what we're doing at work in the workplace. So we know that the job market today is vastly different from even 10 years ago. And then we're going to be called back in about 1 minute. This breakout room will end, but I've got some frequently asked questions here. And the last slide is contact information and some additional resources. Again, this will be put up on the website. Since we have 40 seconds to go, I'll explain in the frequently asked questions. We do have a class, so if somebody's not sure, is this of interest to me? We have a 2-credit class called Intro to Technology. Students can get exposure to different occupations that involve electronic skill sets, learning more about that. If somebody said, I want to take one class and see if I enjoy this, I would have them come take DC electronics, and they would get a really good sense of if this is for them. And about 5 seconds and our window is going to close. Please reach out to me. Any questions? More than happy to talk with you. More than happy to have you, come on into the call.
Also gives us a sense of what you're interested in. So go ahead and fill that out, give us some feedback.